In this video, we'll discuss stem and leaf diagrams. Now, we also call them stem and leaf plots. So either of these names, you know you're talking about these stem and leaf diagrams. One of the nice things about stem and leaf diagrams is that they always present all of the original values. They kind of look like a horizontal histogram or dot plot, but with the actual values in place. One of the most important pieces of the stem and leaf diagram is always the key. So you have to be able to read the key to know what the numbers mean. For example, maybe you see a key that looks like this, where it says 5 has this the vertical bar and then 6, and that means 56. However, that's not the only way it would mean it. It doesn't have to be the 10s and the 1s. It could be something like we've got 71 on the left side and then 6 on the right, and that's 716. Or maybe that's a 12 and then on the other side a 4, and that means 12 and 4/10. Or maybe even 8 and then 7 means 8,700. The key to it is that whatever my leaf is only one digit. It's the least digit possible in the numbers that I have provided in my data set. And then my stems are created with the rest of the number that I have. So in this case, this would mean that all my numbers would go no less than the hundreds place, and I could have thousands or tens of thousands. Now, when we're constructing a stem and leaf diagram, the first thing I like to do is to reorder my data from least to greatest. I find it very helpful to create in this way. The next thing is to create the key. The key will help me understand how to actually create the stem and leaf diagram. Now, the stem can have multiple digits, as we just saw, but the leaves are always the single digit that is the least digit in the set of numbers. If it's the 1s, then the leaves are 1s. If it's the 10ths, the leaves are 10ths. If it's thousands, the leaves are thousands. But the stems are going to change based on what we need for our leaves. First, we create all consecutive stems so that all of our data can be shown. We don't skip a stem because there's no data. We list it as well to help show the spread of the data. Then we draw a vertical line to separate the stems from the leaves. Lastly, we list all the leaves with each of its appropriate stems, and we put those leaves in numerical order as we're constructing it. So let's look at some examples. Here I have numbers that range all that are 1s with 10ths located on them. So I'm going to set this data in order, and I can see then it goes from 4 8/10 up to 8 8/10. Based on this, I would say that the least digit is the 10ths. So I'm going to say that my stems will have to be the 1s and my leaves will be the 10ths. So here 4, and then I put the vertical bar 8 means 4 8/10. So I'm going to create all of my stems first. In this case, that would have to go from 4 to 8. So that's 4, 5, 6, 7, 8. Now I'm going to put a vertical bar, and now I can list each of my leaves. So for the 4, I'm going to list a leaf of 8. I have no 5, so I skip down to my 6s. So I'm going to have 1, 2, and then that's it. Then I go to my 7s. I have a 3, a 4, a 4, a 5, a 9, and a 9. And then my 8s, I have 3, 4, 5, 8. So I can read these numbers and say that means 7 and 3/10, 7 and 5/10, based on how the key is presented. Now, what if my numbers were in thousands? It still follows the same premise. First, let's reorder the data to see what we have. We're going from 6,000 to 8,400, but I also noticed that the smallest non-digit or non-zero digit number I have is in the hundreds. So this makes it easier to use. For my key, I would say that my stem is anything in the thousands, and then my leaf is the value in the hundreds. So the vertical bar 0 would be 6,000. So I'm going 6,000 to 8,000, so that's 6, 7, 8. I put my vertical bar, and now I'll start listing my hundreds. I have a 0, a 1, a 3, a 5, and a 5. In my 7,000s, I have a 1, a 2, a 2, and a 5. And then my 8,000s, I have a 3 and a 4. So these numbers aren't 83 and 84, they're 8,300, 8,400. And that's why the key again is so important. Now we can also use stem and leaf plots to help us find the mean, the median, the mode, the range, the standard deviation. But because all of that data is there, we can utilize it instead of having to have like a set listed like we had at the top of each of those. We can also use the stem and leaf diagrams to help spot trends without actually calculating those specific values. For example, say we want to look at these two data sets, and we have our key telling us that this does indeed mean that 5 with the vertical bar 7 means 57. And they're using the same key, and we know which one would have the smaller standard deviation. Now, it's important to remember from our previous videos, we talked about standard deviation, where the closer the values are together in our data, the smaller the standard deviation. The more spread out our values, the greater the standard deviation. If I look at this left side, the data in this is mostly centralized around 60 and 70. It's a much more compact data set. Whereas when I look at the right diagram, it's more spread out. I've got my most values in the 90s and in the 50s, and then in between a couple values. So it's much more spread out. Because of that, without even calculating it, I could say that most likely the left diagram should have the smaller standard deviation because the data is closer together. And if I want to verify this, I could actually calculate it. And what I will find in these two sets is that the right diagram has a standard deviation almost double that of the left diagram because of how spread out that data is. So without actually having to calculate, we can figure out a lot of aspects looking at different diagrams.